Course 3, Lesson 94, we're looking at graphing pairs of inequalities on a number line. So if you need a refresher on number lines, do that now, okay, and taking inequalities and putting them on our number lines, okay, because we're going to start and look at, okay, if we have a couple different pieces of information like this problem, how do we show that on the same number line? So if basketball players' height range between 5 foot 5 inches and 7 foot 6 inches, we want to be able to show everyone where that range falls. First, it's easiest to convert them into inches to say our heights are between 65 inches and 90 inches. What we're really doing is we can split it up into two pieces of information. Okay, heights need to be greater than or equal to 65 inches, and heights need to be less than or equal to 90 inches. And we can actually graph both of these. Now, this first one here, it's a little bit easier to graph if I switch everything around and say heights is greater than or equal to 65. So that when I go to my graph and say, all right, I have 65 inches here, 90 inches here, well, that greater than or equal to is going to be a closed dot, and I'm going to be going to the right. Whereas the heights is less than or equal to 90, I still have a closed dot, and it's going to the left. And we notice that they intersect. Well, this intersection here, this in-between part, is what we're looking at for our basketball players. Anybody can be between, or anyone is between those heights. Can we have somebody, or do we have somebody that's 93 inches tall? No, it's outside of our range. Can we have somebody that's 60 inches tall? No, it's out of our range. But we can have anything in here. We can have 65, 66, 90, or lower. Okay? Now let's try that with another example. Let's say we have a triangle, and we know that one of the sides is greater than 2 and less than 8. So I'm going to write two pieces of information. I'm going to say, okay, the length of my triangle is greater than 2, and the length of my triangle is less than 8. So I'm going to graph both of those pieces, 2 and 8. Well, the greater than 2, that's just going to be an open dot going to the right, and the less than 8 is an open dot going to the left. We can see that these connect again. Now, we want to take these pieces of information, we have graphed them now, but I'm going to put them in one complete inequality. And so we do that, and let me just change some colors so I can show you. I'm going to say, okay, my length is greater than 2, and my length is less than 8. Now I'm going to switch around this length is greater than 2. So I'm going to say 2 is less than length. That's the same thing. I've just switched everything completely. Switch the sides, switch the sign. Okay, and then I'm going to squish it together with this length is less than 8. So I'd say my length is less than 8. And I have my full inequality. I have 2 is less than length is less than 8. And that's exactly what my graph shows. Okay, my length is between 2 and 8. All right, let's try another one. So we have this inequality, and we start with the combined squished up version. It says negative 1 is less than or equal to x is less than 5. Well, let's split it into its two pieces. Okay, I'm going to say, all right, I have this first piece, negative 1 is less than or equal to x, and I have the second piece, x is less than 5. So I can easily graph the x is less than 5, but I'm going to switch around the negative 1 is less than or equal to x, so I always have my x on the left side. So I switch my x to my negative 1, and I switch my sign. So that I have, okay, negative 1, a closed dot because it's equal to, greater than or equal to, and I'm going to the right. Then I have my 5, it's an open dot, and it's going to the left. Okay, with these type of inequalities, you'll see that they're going to connect. They are going to connect. That's because these are an intersection of information. Just like we talked about with our sets, an intersection is the things that overlap. Well, with these two overlap, I could show it as, I'll erase this and show it again. But I could also show this and say, all right, I have a closed dot at -1 and it goes all the way this way, right? That's my first equation. And I have an open dot at 5 all the way to the left. Well, the only places where it works for both, since I want both, that's my inequality, is in between here. So I could show this as a closed dot, an open dot, and a line in between. Okay? All right, let's keep going. So that's an intersection. Try these before I do them on your own, but you should be seeing we have -3 is less than x is less than 3, which means this is an intersection from -3 to 3, open dots, and connecting in the middle. 5 is less than x is less than or equal to 10. Okay, we have from 5 to 10. Remember, you can split up this information, turn it around, okay, and that'll help you see that I have an open dot at 5, a closed dot at 10, and they intersect. Okay. Now, not every inequality where we have two of them is going to be an intersection. Sometimes the inequalities will have an or in between, which means the lines are not going to go in the same intersecting directions. They're going to go in opposite directions. That's because this is a union. Okay, the other one was an intersection. This is a union. Okay, it needs to be one of the pieces. It can't be both, but it has to be one or the other. So let's graph each of these parts. So we have t is less than 40 and t is greater than 100. Let's say this is people's ages at a conference or something like that, or at a community group. And we're saying, okay, people's ages have to be less than 40 or it needs to be greater than 100. Meaning, can I have a person that is 30 years old there? Yes, because it's going to fall within this range. Can I have someone that's 120? Sure, because it falls in this range. Can I have somebody that's 52? No, because it falls somewhere in here, but that's not part of our solution set. So we can have somebody that falls within one of these, and we're good to go. This is called a union, because we're saying we can have information in either of these sets being true. All right, try a couple more unions, like this one. T is less than or equal to -1, and t is greater than or equal to 3. So I have closed dots here going in opposite directions. These are unions. Okay, so I could have numbers like -2, -20. I could have numbers like 5, 32, but I can't have the numbers like 0, 1, and 2, the numbers that are in between there, because that's not part of my solution set. Okay, so a couple more unions. We see that or and we say this is going to be a union. They're going to go in opposite directions. And so when we see these, okay, x is less than 0 and x is greater than or equal to 5, that 0 is going to have an open dot going to the left, whereas the 5 is going to have closed dot going to the right. This is a union. X is less than or equal to -3, or x is greater than or equal to 3. So we have a closed dot going to the right, closed dot going to the left. This is a union. We can have things like -20, -4, -3.5, or 3.540, but we can't have anything within here. And our last example. A college will cancel a lab class if less than 12 students enroll, but no more than 30 students can enroll in one lab class. Write an inequality that shows the number of students that could be in a lab class. Then graph the solutions. Well, let's start with our pieces of information. Let's say X is our students. So we need enough students to be in this class. We need to have more than 12. Okay, so X needs to be more than 12. But X also needs to be less than or equal to 30. So when we squish this together, we flip all this around and say 12 is less than X. So we squish it together to say 12 is less than X, and X is less than or equal to 30. So that when we graph it on a number line, we're going from 12 to 30, open dot on 12, close dot on 30, and we want everything in between. We can have 25 students in the class, or 13 or 14 or 26, okay? Even all the way up to 30, but we can't have anything outside of that range. And the question is this a union or an intersection? Well, because we have our connection in between, this is an intersection, okay? Because we're looking at the ones that cross, and we cross between 12 and 30. Well, I hope this is helpful for your homework and for studying.